Okay, so this meeting is being live streamed. Thank you so much, SR team. All right then. So since this meeting is being live streamed, let me just begin. First of all, I would like to introduce our guest today. We have Professor Janakiraman Viraraghavan from the Electrical Engineering Department of the Indian Institute of Technology Madras. So, Professor, thank you so much for being here. As an introduction, Professor Janakiraman is an assistant professor in the E department of IIT Madras. He belongs to a very vibrant integrated circuits systems VLSI group. His research focus is primarily on design automation techniques for circuit design and low power circuit design for machine learning hardware. The professor is passionate about teaching, and he also spends a good time working on the methods and presentations that help him reach out to students more efficiently. So thank you so much once again, Professor, for being here. If you can begin, we'll be delighted. Over to you, sir.
Okay, thank you. So, Aditya, what I want to know is essentially this was sort of robotics, this thing, is it, that you're talking about now?
Yes, sir, that is correct. We are talking about robotics and we are talking about IoT and how it can be wirelessly implemented and all those stuff.
Okay, and so my role as a guest lecturer, right? I was under the assumption that I'm going to sort of get an update from you guys on what is happening and stuff like that. Was that this thing?
Yes, so the thing that happened is we had an update, but since everything happened so quickly and we had a lot less time, we couldn't actually coordinate properly. But yeah, so I'll just begin by giving the introduction.
Can you start by giving the update, and then I will sort of chime in with my comments appropriately. Okay.
So I'll just begin by sharing a brief video which I had made earlier regarding the ROBO-SOCCER bot. So that is what we'll be talking about today. And see, since the session, okay, everyone, I hope I'm audible properly because I got a message earlier. Okay, so since this session is basically on IoT and the techniques that can be used for circuit design and the ROBO-SOCCER competition in greater scale, we'll be talking about the implementation of IoT and controlling a robot wirelessly using a mobile phone. Okay, so Professor Janakiraman is our mentor for the ROBO-SOCCER competition for Paradox 2024, and he's here to guide us. Okay, so Professor, we'll just like to have your views on the IoT and the scope of everything in the future and wireless implementation of this technology.
Right. So, before that, can I understand, where you guys are with respect to the ROBO-SOCCER? Because you had sent me some pics on, WhatsApp and stuff like that, right? So I'd like to understand, what are you guys trying? Where are you? What is it that you're attempting to do and stuff like that before we get into this thing, okay?
Right, sir. So if it's visible, I have presented a video of the robot that was built using a plastic box. This was a choice that we had given the participants in case they didn't find a metal chassis in time. So we'll just let the entire video play. So while it's going on, I'll just explain what's going on. Okay. So what we have here is a plastic box. Most electronic system students may already be familiar with what's going on. So this is a box that in which we received our electronic components. Okay. So this is what I had repurposed. I had 4 holes marked on either ends, and I made holes using a soldering iron. So after that was done, I also made sure that the holes were on the exact opposite ends, as I've already mentioned earlier, to prevent the situation of skewed motors. That would be very bad. Okay, so what's going on here is that I've carefully marked the holes, and the holes were made using a hot soldering iron. Although the soldering iron is not actually meant for this purpose, I just used it because I just wanted to repurpose this box into an actual robot that will play ROBO-SOCCER. All right. So this is how it looks after making the holes. Make sure you align them correctly, and the motors have been placed like this, so it can be screwed inside since they already have the threads in them, okay, on the top side of the motor. So once that's done, you will notice that the shaft goes through, and this is where you'll be attaching the wheels. Okay, so I'll just give you some time to look at what's going on in the video.
Yeah. So how did you do the alignment across the two ends?
Well, I measured the distance between the two. I mean, I measured the distance across from the shorter side of the robot. I took that to be the behind of the robot. So I calculated equal distances, which was about 5 centimeters. So on one side, I marked 5 centimeters, and on the other side, I marked 5 centimeters, and I just marked a circle and melted them using a soldering iron.
Okay, so no. What I meant was along the width, right? Because you have two independent wheels here. It's not a single axle.
Yes, that is correct. So we have two motors, which well, this is planned to be a two-wheel drive.
Yeah.
Each wheel has independent motor control, so
Okay.
it will be easy to maneuver the robot. So
Also,
after that
sir,
is done,
I'd like to point out here, Aditya, one sec. See, we are making it rather easy so that other people can also follow along. And I'm sure all of them have plastic boxes lying around. So
Yeah.
that's why we're making accessible to all of them.
Correct. Okay. Yeah. Okay. I understand that. No. I'm okay with the plastic box. So basically, because you don't have an axle, you don't have to worry about the exact alignment of those two holes, along the width.
yes,
Right.
Professor,
I mean,
that is correct. So the exact alignment doesn't really matter on that scale, but it is recommended that they are more or less on the exact opposite.
I know. So I think even if you eyeball it, you'll be okay there.
exactly.
Yes, sir, that is correct. That is correct.
Okay, I understand. Yeah. Okay, now what about the, how are you going to control the motor and all that?
Yes, sir. So on your screen, the video I'm presenting is where we attach the breadboard for a temporary purpose, where we attach the Raspberry Pi Pico W, which already had the header pins which already came pre-attached with the header pins. So
Okay.
what we did was we attached it on the breadboard, which was attached to the robot using two-sided tape. All right, and the main reason we used a breadboard with header pins was to completely eliminate the need for soldering, because we noticed that many people didn't have experience in soldering. So what we made sure is that they had the header pins connected, and they could connect the motor to the breadboard, and that's how they'll be able to control it. So in the video, we'll also be able to see that I have made another hole in the center for a caster wheel. But in place of a caster wheel, we gave the students the option to use two more wheels in the front in using two motors. I mean, they could use two other motors, so that would make a total of four motors. Or they also had the choice to use a rod and then attach the wheels to that. So it will be two motors plus two wheels with a free moving rod. So it will be a free axle. It is not powered. So, but in the video, what I've done is I just made a hole in the center and I attached a wheel which I repurposed from an air cooler. So this was my attempt to have it made very cheap. And yeah, so on the screen, this is what I had.
Where did you get that wheel from? The front wheel?
That was repurposed from an old air cooler. It was from a fan.
From a fan. So where do people get that wheel now? Because that looks like one of these suitcase wheels or something, right?
Yeah.
Sir,
So
it's
it
just
was
a caster wheel.
repurposed
It's
because
available online.
I had one laying around. It was broken, so I repurposed that. But the thing is, if the students want to buy an actual caster wheel, okay, so that is not a caster wheel what I used. A caster wheel in any electronic store is available for 60 to 70 rupees.
Okay.
So it is not that much of a difference. I just used it to show that the robot can be made in very less money. It can be made as cheap as possible.
So, okay, so the independent control of the two wheels is basically so that you can do turning and all that. Is that the only reason?
Yes, sir, that is correct. That is correct. So, in order to turn left or right, see, for example, in order to turn left, the motor on the left will go backwards and the motor on the right will go forwards. So, it will be sort of a yawing maneuver, which will make the robot turn left.
Yeah, got it. Okay, good. Go on.
Yes, sir. So, on the screen right now is my attempt in attaching the motor driver. And I've also explained the connections in the motor driver in the previous workshop. So this was the motor driver which I used. So this was attached on the top right corner of the robot. And again, since it already has header pins on the top that can be seen, it eliminates the need for soldering. So this component is what controls the motors through the Raspberry Pi Pico W controller board. Okay, so that will be connected to the Raspberry Pi Pico through the breadboard once again. And all in all, that is how the robot will be controlled. Okay, the power supply is will be taken in another workshop. So this is how far we have come.
Okay, fine. So now, what is the mode in which you are going to control this? How are you going to control the robot?
The robot is going to be controlled through a wireless mode through the participant's mobile phone. So what we have is we have a UF2 file that is loaded into the Raspberry Pi Pico W through a process where we connect it to the computer and we load the UF2 file, which is basically MicroPython. So we can also code the UF2 file in C or C++ and make our own UF2, but in the workshops we'll only cover the UF2 file which already contains MicroPython. So it will be easier for the students and it will not consume a lot of time too.
Okay, that is good. But now my question is how, so when you say ROBO-SOCCER, I'm assuming many people are sort of, there are many robots in that field, right?
Yes, Professor.
So how are you maintaining, the identity of each mobile talking to that robot separately? And what is the protocol that is being used to communicate with this robot?
It is mainly over Wi-Fi. So the Raspberry Pi Pico W has both Wi-Fi and Bluetooth functionality. So we are using Wi-Fi. Okay. So the UF2 file, which I explained earlier, has a program where it searches for the user's the owner of the robot's Wi-Fi from the mobile phone. So after he enters a password through a secure form, he will be able to connect it. Okay. And we have an interface where it is in simple words, it is coded like the remote control of a toy car. So we have on the screen, we have forwards, backwards, and left and right on the other side. So that's the interface they have. So once they connect it wirelessly through the Wi-Fi capabilities of the Raspberry Pi Pico W through their mobile phone, they will be able to control the robot. And we have also taken app precautions and care wherever necessary to ensure that at a time only one person is able to connect. So
at a time, only one person?
At a time, only one person, which is the owner of the robot, is able to connect because it is password protected. At the same time, it is over a secure internet. So there is no chance of anybody hacking or controlling anybody else's robot.
Okay, so let me ask you this. Have you guys ever tried to do a remote control car race?
Yes, sir, we have.
So what happens, what's the primary condition in order to have a race there?
The frequency should be different so that they don't interfere with each other.
That's what I'm asking you. The frequency should be different, right? So in the remote control car, you have the option of setting the frequency to different gigahertz.
That is right.
And only then 3 people at a time can actually have a race. How is that happening in this? Is my question.
So, sir, the thing is, like, we have our mobile phones, right? They connect to a Wi-Fi network. And then once they are connected, it's only that network with which they interact. And I think that is what we are following. As a matter of fact, Raspberry Pi Pico is one thing that we are like teaching people, since it has a lot of possibilities. On the other hand, we are also giving them a free hand wherein they can use anything, whatever they wish to. And as a matter of fact, something on similar lines, I used ESP, which is, I mean, not the latest tech, but I just tried to show them that it is possible to make it cheap. And if you just allow me 1 second, I hope it's visible.
Yeah, I would like to add a point to Namai that, sir, the Raspberry Pi Pico board has a specific IP address, so the frequencies will not be interfering to each other.
No. See, I think that's where, because you're using this Raspberry Pi, some of these details are getting abstracted out. Okay. And as electronic system students, you guys need to get into these details and understand how it is happening. Okay. So I'm perfectly okay where in this particular competition, your focus is just to get it to work, show a nice robotic football match. Great. That is fantastic. But I also expect you guys to get into the nuts and bolts and figure out how these two frequencies are not interfering with each other. Right? It's just not about some IP. It might be some specific encoding, for example. right? You all might be talking on the same frequency, but you all might be encoding this with a different kind of a spread spectrum or something like that. I don't know, right? I have no idea what's happening there. But I'm saying you guys slowly and steadily should get into these details. Okay?
Yes, sir, you are right.
Okay, yeah, that's the ultimate aim. The aim is not just to do this like you saw in the
Right, sir.
uh,
As you just
electronics.
pointed out, it is a, I mean, very important detail. Correct.
Okay, yeah, so that's great. Yeah, what are you showing, Namai?
So, sir, this is something that I tried to make. This is four-wheel drive, and this is essentially what it looks like. Uh, it has this kind of a front U shape with which you can actually play soccer, and it's basically an app-based thing. So this is how, I mean, I made it. Again, this was the motor driver, and I use ESP 8266. And then I use this 3S LiPo battery. I mean, again, this was very basic in nature, as in all of these motors was just hot glued in place. And basically, I was just trying to show that even if with basic materials, you can make something which is very cool. And this I feel is very fast. So
Oh, very nice. So, okay. So another, very naive experience I had with respect to remote control cars, right? When I was working, for some reason in my office, they decided to have a remote control car race. Okay. And they set up these tracks. So each of us went, I mean, I already had my remote control car. Other people went and bought all fancy big cars. Okay, I mean fancy cars that could go really fast. And it turned out I won the race simply because my car was more sturdy and it was more steady, right? And therefore I simply won. People just couldn't control it. So I think be careful about trying to make it go too fast. You can't control it in that case. Okay, that's just a a cheat trick to win the competition. Okay.
The driver still
correct,
would
sir.
be more responsible for winning the competition.
Yeah, exactly. So that skill is non-trivial. Okay, it's not at all trivial to control a car that's very fast. Okay, I realize this. It takes a lot of practice, especially if the floor is very slippery and all that. It's even worse. Okay, so it's like my big heavy car actually won the race without any competition that day. Okay.
I was working on a project myself, and I accidentally made it too fast. I'll probably show it to you when we meet. But
Yeah.
yeah, I'll definitely bring it. I was working on a Tesla Cybertruck model, so
Okay.
yeah.
Okay, so now next, my question is: all this code, right, for controlling the the wheels and the motion left, right. I see that, right? I mean, that's a very nice idea. It's basically like a joystick that you're sort of making on the screen, right?
Yes.
Turn left, turn right, and all that. So, what is who? I mean, did you guys write the code for that, or was it already available?
That code, Professor, I wrote it by myself. It was actually, well, not completely from scratch. It was one of my previous projects that I had in 11th grade. So that I had some modifications made to it. And also, Professor, one important point I would like to make on your question. I was disconnected, unfortunately.
Yeah.
You had the question on the wireless connectivity, right?
Correct.
So I would also like to mention that we have unique IP addresses for each person. So whenever he
Yeah,
connects,
that I have told Professor Aditya.
Yeah. No, Aditya, my point was like slightly more fundamental. See, unique IP addresses and all is slightly higher level on the communication stack. Okay, at the nuts and bolts level, ultimately, your whatever information you're sending is going over a 2.4 gigahertz signal or something like that.
yes, sir, that is
Then
correct.
it's getting decoded at the other end, right? Now, what prevents that from decoding another guy's signal might be some specific key, right? I don't know what is happening internally. I'm just saying that you guys need to go beyond just making this work to actually understanding the theory behind that. Okay, because already in the electronic systems thinking course you saw why you needed different carrier frequencies for different signals. Now if somebody is sending signals on the same carrier frequency, please do figure out how they are not interfering with each other. Okay, so it's equally important to jump into the theory as it is important to getting something working.
Yes, sir.
Sir, I
I
feel
completely
with your
understand.
routers,
So it's the same
they
concept as in it's the same concept where we have, for example, multiple Wi-Fi routers in the room. So what one can notice is that whenever he turns on the Wi-Fi in his mobile phone, he'll notice that there is a list of all the Wi-Fi routers in the room. So he
Correct.
can do any one he wants. So since you mentioned that is the theory that we need to understand, we need to learn how that works.
Correct.
Since there is no interference, and well, that happens to be the core idea of RoboSoccer bots in the field, since there are going to be a lot of them at once, but together in a round there are going to be only two. So there is only two robots that we need to handle at once. But I definitely agree on your point that we need to learn the theory on how these things work,
So you guys have
and
tried
that there is
you guys have
experience.
tried multiple robots and all that, right? Because what I don't want is on the day you try something and multiple robots don't work or something like that.
No, sir. There is no problem about that because we ourselves have 6 or 7 robots that we are bringing along with the participants robot that they bring.
Okay.
But the important thing here is that in okay, we have an arena like just like a football ground, and in that arena we are going to have each round of 5 minutes.
Yeah.
So and at a time there are not going to be more than two robots. Only two robots in each round every 5
Okay.
minutes.
Okay. 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 Excellent. No, that's okay. See, 2 or 3 doesn't matter. Once you're more than one, I don't think it matters because the same idea can work across the robots. Okay. So that I understand is you're keeping it down to 2 because of some logistical reasons of the arena size and all that. So that's okay. Yeah. Okay. Anyway,
also,
yeah.
sir, to avoid like the interaction and disturbances, they kind of they keep shifting their phase angles, and uh, if it's advertised to be 2.4 gigahertz, so they'll send frequencies slightly above and slightly below it for a stable connection. But
Yeah.
yeah,
Yeah.
agreed.
What I'm trying to say is please do eventually. I'm not saying now, right? When by the time you finish this degree, you should have an understanding of how these things might work. Okay, that's the point I'm trying to make.
Right, sir. That
Correct,
is
correct.
the best. But that's the best thing that we have as a part of this degree.
Yeah.
So also the RoboSoccer event at Paradox 2024 this year. It is a precursor to the interesting things that is going to be covered in the upcoming embedded systems courses that we have in the electronic systems program.
Exactly.
That we have. So it's going to come in the June 2024 term. So that is all that we are going to learn, and even more interesting things coming up. So this was in fact sort of an introduction that we plan to give the students in the ES degree, along with something that they could use in real life to win competitions.
Sure, sure, sure. Excellent. Okay, very good. Yeah.
Okay, sir. If it's all right, then we can start taking questions of the
Yeah, yeah.
people.
Sure, sure, sure. Yeah. Let me see if I have any other because I wanted to understand this a little bit better. Wait. Okay, your code, to turn and all that, right? So I mean, it's like what? Is it a continuous thing or is it a quantized thing? Let's say I hit turn right, it will turn by like a quantized number of degrees, or what will happen? Or
It will it see the thing is it will turn as long as you're pressing the button. So what we have coded is that as long as the button on the mobile phone is pressed, we send maximum power to the motor. So as long as the button is pressed, the motor will be turning in its maximum RPM, which is 300 RPM. So there is nothing like degrees or something that we have coded. It is just when it turns right, the motor on the left will go towards the back, and the motor on the right will go front to turn left. So we program to deliver maximum power to each motor. So yeah, and we didn't use anything where we turn it using degrees or something.
okay, but is that not too fast?
Not necessarily, because what we experienced is that we took a couple of examples from people who were controlling their remote control cars. So we have a couple of people in my neighborhood who are professional RC enthusiasts who have those heavy duty RC cars and all. So the thing with that is when they tap their mobile phone, well, they have RC controllers, but what I experimented is when they tap their mobile phones, the motor will turn only for that duration. So it
Yeah.
is not that it delivers a constant 500 a 300 RPM immediately. So it has sort of a rubber band effect. So it turns fast up to 300 RPM, and when the button is released, it slows down.
But sir, I believe this is highly subjective in nature. It depends from motor to motor. For reference, the one I used, see, since it's electric, right? All of that torque and all of that RPM gets delivered to the motor in one go, and that's why the app that I used, that has a slider. So you can slide it, you can reduce, the top speed, and then when you press it, it'll turn accordingly.
Oh, okay. I
Yeah,
understand. Okay. So you are able to control that speed also.
yeah, speed as well.
Okay. So technically, you can actually have this guy rotating in one place forever, right?
Yes, so that is
That's what
possible.
I also showed in the video. It was a
Okay.
really nice
Yeah,
tank
yeah, I
motion.
remember. Yeah. I remember that. Okay. Nice. Right. Okay. So I guess let's see. So it's basically just a one-on-one sort of a game here that you're talking about, right?
True.
Yes,
Yes, sir.
Professor. So it's going to be one-on-one, and all the participants that we currently have a confirmation on 13 robots that the participants are bringing. If there are more, then we can add them to the hierarchy of the round. So it is going to be exactly like a football match. The only thing is that instead of two teams competing, it's just going to be two robots competing.
Okay.
So the winner of each round will move to the next round, and so on.
Okay. Excellent. So what is the rating of this motor, by the way? How many watts?
It is, I believe it's 12 volts, 1 ampere, if I'm not wrong. It is 300 RPM, so we have a couple of rules that we set.
Oh, it's a 12-watt motor.
Yes, sir.
So the thing with these motors is that even if you, for example, the one I used, it's rated for 6 volts. Even if you give them 12 volts, it will run perfectly all right. In fact, the RPM would increase and the torque would increase. So motors, unlike LEDs, you don't have like a capping. Of course, you have a cap, but then that cap is like way above what
Yeah.
they're rated
No.
for.
I understand. I'm just saying that, which means these are actually very powerful motors.
Yeah. These ones are very,
And
very quite
where is the battery for this coming from?
A battery, we have given the competitors a choice. If they have lithium polymer batteries, they can use it, but we recommend them using a power bank, a 20,000 mAh power bank that they can use with a step-up converter. So if there is a 5 volts, then it can be stepped up to 12 volts, and there is also no issue of current because many people they may not have an access to a lithium ion or a lithium polymer battery. So we have given them the option to use a power bank, which obviously they may have at their homes to charge their mobile phones.
Yeah, but is that not too heavy?
Sir,
No,
I believe it is.
not heavy because we have well, in the arena inside is going to be 4 meters by 2 meters. So we have we have those stretch material high friction mats that we are going to use.
Yeah.
So as long as the motor is 300 RPM, I would also like to tell that the lightest robot for this scenario that I built was under 2 kilograms. So that was more than enough to keep the robot at sufficient speed when playing soccer.
Okay.
So weight is not a matter, and to keep that in mind, also we have in the competition we have set a limit of 3 kilograms for the robot. It cannot be more than 3 kgs.
Okay, fine. Okay, good. I think I'm done with all technical questions that I had.
Well, lastly, again, this is also subjective in nature. Since I used four motors, see a power bank, an average power bank, it maxes out at 5 volts, giving out 2.1 amps, right? That gets us a 10.5 watt.
Yeah.
But for my four motors, it wasn't enough. So you can't really drive that with a power bank. So I used a 3S LiPo battery.
Ah, okay. Interesting. Okay, good.
Because then the moment you boost the voltage, right, and make it 12, your amperes, it drops down to 0.8 amps, which is like nothing.
Yeah. Of course. So that's why the stepping up is not so easy.
Exactly.
Exactly. Right. So okay, that's good. So you will see this phenomenon everywhere, actually, right? The moment you step
Sir,
up voltage.
ESTC came in so handy while I was preparing for this. Also, I knew this before even I did this course, but after studying ESTC, everything was like so crystal clear.
Yeah. Nice. Very good. I think that was the aim of the course. for you to realize that theory and practice are not far from each other. You can tie them together.
Correct, correct.
Okay, excellent.
One of my favorite courses for sure.
Excellent. Very good, man. Thank you. Good. Thanks for that feedback.
Yeah, we knew each and every basic nuts and bolts of
No,
this.
no, sir. As a
Robotics
matter of fact, thank you because you taught it so well that every concept was clear.
Excellent, man. Good, good. Happy to know that. Okay, so let's move on.
Yes, Professor. So we'll start with the questions that we already had regarding Internet of Things, IoT, and the future of it as a hobbyist and whatnot. So as an electronic system itself, and along with that, we also have the questions from the participants. So we'll also take that. Okay. So the first question is from Team ROBO-SOCCER itself. We had a couple of questions that we decided.
Yeah.
So the first question is, in the past few years, embedded systems and IoT has become so affordable and easily available to every enthusiast and hobbyist in the nation. Where is India headed in terms where can reach? Sorry, where is India headed in terms, and where can it reach in the near future as a nation in this field?
Okay, so this is a very interesting question, and at the outset, let me state that I am not an embedded systems expert. Okay, but I will try to answer this to the best of my knowledge. Okay, just give me 1 second. Okay. Yes. Okay. Okay. I sent you a link. Can you guys click on that?
Yes, so we'll open it.
Okay. So you see some sort of a 4-wheeled vehicle moving, right?
Yes, sir.
Yes, sir.
It looks like some boat or something.
Yeah. So what do you think that is?
It looks like it's used by farmers in harvesting the.
It appears as some sort of a machine tool that farmers may use it to sort their vegetables according to.
Okay. Excellent. Okay. Good. Machine for farmers. You are very close. This is actually to pluck tea leaves. Okay, this is a tool that a company I know builds to pluck tea leaves. Okay, so if you look at this, that's why you have these wheels which are below, and the machine is actually quite high. Right? Do you see the machine? You see that the rotating shaft and all that is actually quite high from the ground, right? So actually, the tea plantation thing falls right in between the wheels, and the robot just goes along, chopping off the top of the tea plantation. Okay, and then of course the robot basically moves down to the next step and then comes back. Then next step it goes down. So it basically has to move on really rugged terrain. Okay, and it is so why am I showing you this? Well, this you already see that this is not very different from what you are trying to do, except that is this is a real life application that we are talking about. Okay, so apparently the labor and the thing available for tea plantations is sort of dwindling down very quickly, and that's why we need such robots to sort of provide that kind of skill to these tea estates. So there is this company that I have requested this company to come here during the Paradox program and at least have either a small demo or an interaction with you people, so that you also see what kind of products are available out there in the market. Okay, the thing is, these are not the multinational companies. Okay, these are sort of the medium scale companies that cater to such products. Okay, and what is happening is there are a lot of such products that can be built specifically for the needs of India. Okay, this may not be applicable in the US or anything like that, but we have 1 billion plus people, right? 1.4 billion people, and there is a huge market for such products here. Okay, but the problem is there is no skill that can actually do this. So the number of people who can actually do this kind of embedded systems programming, I mean, some of you already are, you have a feel for it, right? You know how difficult it is. lack of documentation, lack of standardization, all these problems, right? So it just requires a different kind of skill for you to sort of to build such products. Okay, so I feel there is a an enormous potential for India to grow in this field of embedded systems, and you will also see that this electronic systems is now part of every single field, right? There's not one place that you can, one product that you can think of that does not have automated control or something like that, right? Cars today cars are probably more electronic than they are mechanical, right? This is the truth of the matter. You can simply program, how long you need the braking to happen, how long this has to happen. Everything is programmed in a ROM, right? And when you go there, that guy doesn't say, okay, I'll open and check your engine. That guy says, okay, I'll reprogram something and give it to you, right? So clearly electronic systems has a very fundamental role to play there, and that is precisely why we started this program of BS in electronic systems from IIT Madras. Okay, we need to produce engineers to fill the gaps that are available across the spectrum, right? So essentially we all want to sort of move and address all these products. It's not just the multinational companies, small scale, medium scale, at all levels we need people who are able to sort of address the needs for our country.
Sir, as we all know that debugging is a labor-intensive and time-consuming task, so it is so challenging for human workers. So this robo can be a huge success also.
Exactly. So that's the reason I am trying to request them to come here and give a talk or a demo, right? But it is very interesting. Okay, if you look at these small-scale companies, right, their language of communication is actually in Tamil, because they're basically based out of Chennai, right? The CEO is a Tamilian, so if you look at it, it's a very different environment from what we see in MNCs and other places. It doesn't mean that the learning is any less, right? In fact, you will get trained much better there, if you're this thing. So it's very interesting, how these things work, right? So it doesn't mean that only if you know Tamil you can work there. That's not the point. That's not the point I'm trying to make. I'm just trying to say that the way things work, the culture and all that is very different, but it is equally useful compared to other big companies that we know.
Yes, that was a really huge revelation that we had, especially in the field of electronics. So the one question that we all have in this, the students who are in this electronic systems, BS in electronic systems degree, is that after we complete all the courses and after we complete this 4-year degree, will we be able to design something, or will we be able to innovate on something that may, something like a fruit salter that you just showed, or a tea picker?
Yeah.
So will we be on our own? Will we have the capacity to design an electronic component and use it for such applications?
Okay, so will you be able to design? That is, I would say you will definitely be taught enough skills to be able to design such a product and stuff. In fact, we do have a course later called electronic product design, just about how do you come up with a product spec, how do you come up with a product design and stuff like that. So yeah, but will you be able to create? Well, that is a very small fraction of people who actually can create, right? So that has nothing, creativity has nothing to do with the education we impart. That is something which is very personal and it should come from you, because creativity can come even today. You don't need the education for that to happen, right? It should come from you right on a daily basis, right from what you are doing. Is there a better way to do that? Is there a better solution for that? You can come up with a product on your own right away, right? If you're telling me that all the successful products came from universities, I just don't agree, right? Most successful products came out of people who dropped out of college, right? So it doesn't mean that college education is not useful or that you have to drop out, right? Those are exceptions. But what I'm trying to say is being creative and coming up with ideas is not necessarily tied to education, right? And that has to be a way of living for you, right? If you look at Steve Jobs, you look at Bill Gates, all these people, right? it's a different game that is there, right? It's about saying, okay, there is something here which is very difficult to do, right? I think I have a simpler way of doing it, right? Now, it doesn't mean that you need to be able to understand what a watt means, what amperes means, what milliamp hour means. You could still come up with a great solution, right? But at the same time, it's also important to understand the theory, because that's when you will be able to design to a spec, okay? And you will be able to improve your product, right? What happens is there are various stages of creativity. Usually the first product that comes out need not be the most efficient implementation. It may just do the job very well. But going forward, you might want to, like, you just take your own ROBO-SOCCER event that you're talking about, right? There are so many places of improvement that I can already see. And I'm sure you guys have already sort of recognized that, okay? So in order to sort of make a very efficient design is when you need to know the theory and the nuts and bolts of the theory, right? But creativity is something that can come anywhere at any time, and it is highly recommended that you don't put this creativity off for 4 years and wait for you to graduate with a degree before you start creating things. Start today, start right away, and then you improve it with your theory.
And Professor, thank you so much for that input. And we do definitely have a lot of improvements that we have taken note of, that we'll be implementing in ROBO-SOCCER 2025 for the next year's Paradox.
Yeah.
So I hope everything turns out well for this year as well as next year. So right now, I think we'll take a question from the participants. So let me just open the Q&A tab. Okay, so Govind Soni is asking, how can a person with data science and artificial intelligence background and an interest in electronics make a good career in it?
So is the question that your primary degree is in data science and you are looking to do something with electronics, or is the primary degree electronics and you want to do something with data science?
The primary
his primary degree is data science and AI from IIT Madras itself. He has an interest in electronics, so he's asking how can he probably mash the both of them and make an excellent career out of it.
Okay, so I think honestly, I will tell you that the reverse is easier to do. Okay, and in fact, that has been, if you look at the number of admissions into data science, actually it's much larger. So in all my interviews, if you would have noticed, I would have said, look, it's easier to get into electronic systems and then pick up the skills that are needed for data science, right? And there is a reason for this, okay? Because essentially in electronic systems, you do linear algebra, you do probability, you do all the math that is needed for data science as well, right? It's just that you don't do the courses which are sort of, give you the expertise. But those are courses that you can do as electives, right? For example, in the electronic systems, then we can easily create a set of courses which will give you expertise in data science and make you eligible for jobs in the data science field as well. Okay, so usually I have recommended the reverse. I'm very happy to get this question where there are people in data science who have interest in electronic systems. I strongly recommend you move over to electronic systems. Okay, but anyway, forget it. So that may not be possible. So this is just my marketing from as the electronic systems coordinator, right? But again, I would say, if you are genuinely interested, right? Well, I would just say that there are enough material available online today for you to please watch and learn and sort of go ahead and implement your ideas. Okay. The only thing is the number of courses. For example, if you want to understand the circuit properly and stuff, it may not be possible to understand a transistor circuit straight away, right? If I give you a transistor with a couple of resistors, capacitors, it may be hard to understand that because there is a lot of basics that start right from electronic systems thinking, then the electrical circuits, and then you go to transistors, right? So in that case, picking up all the theory may be hard, but you can definitely pick up the practical aspects and just go ahead with your design. So a lot of people design stuff without knowing the theory. So definitely that aspect you should be able to do and still make some headway into the electronics side as well.
Exactly, sir. So I believe that is the main reason during the inauguration of this ES degree, many people were asking if they will be able to do this data science degree along with electronic systems as their dual degree. So I believe that is the thing which drives most people. And thank you so much for your inputs on that as well.
Yeah.
So I think, so I think Charles has a question. Is there an option to take electives in BS in electronic systems for AI and data science in the degree level?
Yeah. So definitely you can take, for example, you can take some machine learning courses, you can take. So what we are doing is some of the courses we are not even going to create again from electronic systems. We'll just point you to those courses, right? The machine learning courses and stuff like that. Definitely if you want. So the only thing is you will have to take all the prerequisites that come along with that course. If machine learning requires you to do probability and statistics, you have to do the prerequisites and only then you can take those courses. So we are definitely going to enable all of that.
Right, sir. So it is also a nice thing that we have electives just like any other college degree. So I believe that was the main reason why this can be compared to any other 4-year equivalent degree, and such as ECE and something similar. So, Professor, for today's session, do you have any opinion on how, talking about electives and the courses, for the advanced embedded systems courses or IoT related things? So, is there any scope for we as electronic system students for that?
No. So what is your question? What do you mean by scope for advanced embedded? I didn't understand that part.
As in, will we be able to learn the things as in, see, in the last couple of months, there has been a lot of advancements in the same field. So will that be taught to us in the coming courses? Because that is the cutting edge of technology, right?
Correct. So for example, see, in the basic course, we will see each course has a focus. Okay. Just because there are advancements, it doesn't mean that those things can be taught in basic courses, right? So your first introduction to embedded systems, right, might be a very basic introduction, because even though some of you might be familiar, a large fraction would not have even seen, what embedded systems is. So therefore, the focus will always be to design a course in a hierarchical step-by-step manner. Okay, none of this will just be, we can't suddenly, because there is a talk of AI in hardware, right? We will not just introduce AI in hardware to you guys just like that, right? That is an advanced research topic. It may be made available to you guys as part of some elective in the higher semesters, right? Or some of the research that we do, like what I do, AI on hardware, it's not even taught in a course, right? It might be available only as, you get trained as part of an internship or as my student and stuff like that. So definitely we will make you, what I can guarantee is we are very much in touch with industry folks. Many of these courses, we are looking at least having an industry consultant, okay, so that we are sure we are not, teaching something which is slightly obsolete. We definitely get inputs from them, and we will make the material available to you in a very accessible yet in a very, I would say, contemporary manner.
Of course, sir. So on that note, we also have a similar question based on the same related discussions that we were having from Mackie. He is asking that robots also have mechanical parts as per my knowledge. So how can I get started with that part if I'm learning electronics from here?
No, you're talking about, so you're saying robots have, so you want to get started on what?
Probably a part that the robot uses, such as a motor or something.
Yeah. So see, okay, this question is open to interpretation, right? So in fact, that's why I even asked them the question, right? How did they synchronize those holes, right? You need those skills also if you're trying to, run both wheels with a similar axle and all that. Okay, so you need to figure out the mechanical part as well if you want to get those aspects right. And I mean, I would just say the answer to those is just look up Google, right? There will always be a do-it-yourself video that tells you how to actually make these holes aligned correctly, nicely, okay? And you should be able to do it. I'm sure there are many ways to, just today Google do-it-yourself videos are amazing, I tell you, right? Personally, I'll tell you that I have fixed my iPhone multiple times with such videos, right? I opened screw by screw, opened this thing, put my phone apart completely, right? I have 20K phone, 30K phone is just on the table in front of me. I'm just hoping it works when I put it back together, right? I've replaced a screen that broke during the pandemic because there is no, I could not even order from Amazon. What do I do, right? So I basically, luckily, I don't throw phones. In fact, that's why you saw this phone dismantling happening in the electronic systems video.
Yeah, in the ESCC first session.
Yeah, because that was my own phone, right? And I just never throw it, right? So one thing is, in the electronic systems thinking course, I did not buy a single of those products. Everything is mine, which was obsolete, not used, but never thrown, right? And I just kept it, hoping someday I would use it, and I got to use it in this course, okay? But anyway, I'm just saying the screen broke, and my wife's iPhone 5S was there, which was available at home. She was not using it because that was damaged. The board was damaged. Overnight, I sat, saw this video, and swapped the screens. So in the pandemic, there was no other way I could get it done. Okay, I could not even buy a new phone, remember. So it's not that you have the money, you just get something done always. No, sometimes you can't do it, and you just need. And it is unbelievable how good these do-it-yourself videos are. Okay.
Agreed.
It's just
for the sake of learning and to see how things works, we need to do these things.
And sir, maybe we wish to see like a proper demo in the next lab sessions.
I don't know. These demos are hard because it takes a lot of time. See, one thing you would have noticed in my videos when I did the demo, I didn't put the phone back. So I didn't dismantle it in a way in which it could be put back actually. I just did it to show you the phone, right? But if I have to put it back, then I have to keep track of every single screw very carefully, okay? And the damn problem with these phones is these 3 screws might look identical to the naked eye, but these screws they are not exchangeable, right? When you try to put it back, you will see a slight mismatch somewhere and then it will not close. So you have to go back, find out which screw goes where. So you have to keep track of this very carefully. Okay, you must do it very meticulously, very carefully, and only then you will be able to get it, successfully. So demos, I'll see next time if I do some replacement, I'll try to record it. I'll try to do it in the studio. Okay, and we'll see what happens.
Sure, sir.
Okay? Yeah.
Sure. So we are definitely looking forward to that. And I would also like to tell you that just like you, I also have a habit of taking apart electronic components.
Yeah, sir. Same here.
So my parents will be a better person to talk to regarding that. We have a lot of things which I took apart and I never put back. But the thing about it is that there is a lot of learning experience that we get. So for example, when I was in 6th standard, I took apart a washing machine that was already damaged. So I got to see the drum and all and the components from behind. So there were a lot of buttons. So that was basically how I got into the field of electronics, right? So that was where my interest started from.
No, but you're absolutely right in the sense that is where the excitement and the curiosity peaks, right? You get to see this and then you figure out you want to know what it is. You want to, then you start repurposing something that was not meant for that task using something else, That's how it starts. So that's a very critical thing, and parents should encourage it, right? So, yeah, so if an electronic component is at, if you are at a stage where you're going to throw it, right, then there is no harm in taking it apart and seeing what happens, because at most you could fix it, which is only a benefit from there. You would have thrown it otherwise, right? So I strongly recommend experimenting on such things. Okay, don't do it with high voltage stuff because that is dangerous. That's my only advice. Okay, don't try it with electrical stuff, 230 volt stuff. With 5 volts, nothing can happen. Okay, so just go ahead, play around, and you learn a lot.
Absolutely, sir. And we would, as a responsible person, I would also like to tell people in this meeting, if they are planning on opening any mobile phone, just be careful with the lithium battery. Make sure you don't poke it or manhandle it, because that's extremely dangerous. You don't want to learn it the hard way. So, as Professor mentioned, it is always advisable to open anything, any electronic component that is anyways being thrown away, to learn something, because that will definitely kindle some sort of imaginative or some interest in you, just like it did for me and many other people over here. So, on that note, Professor, we have a question from Aditya Kumar.
Yeah.
He would like to know that what are the skills required in any applicant from the electronics industry for the embedded systems and Internet of Things, or any electronics related fields, to step into the industry?
Okay, I would defer this question to later, because I don't know the exact answer to this question. But what I can tell you is, we have a couple of talks that have been arranged during Paradox that will specifically address this question of yours. Okay, so please do come over. We have people coming from the industry, and you will essentially get the answer to these questions when you come here for the Paradox program.
Right, sir. So, Aditya, so I hope that answers your question. And I already know that you're in Paradox for the hospitality team. So, thank you so much for all the things that you're doing. And session links, I think the professor was referring to offline sessions. So, the link is you walking over to that place and coming over there.
Correct.
So, yeah. So, I hope that answers that part. We also have another question. Let me just open it.
So incidentally, by the way, along with those talks that we are planning to start in Paradox, we will be having a talk every month or every 2 months. We'll bring in some expert from the industry, where they will address, the kind of problems they are working on. We'll have a talk series that starts with the Paradox program.
Right.
I think
this is good news, actually. This is
data science already has this.
As we can see, there are a lot of people celebrating in the comments, and everyone is happy to hear this. So thank you so much, Professor, for that amazing news. And we have also one important question from Akhilesh Kumar Bhagat. And I believe this is one question that many people who aim to have their own startup or something similar have. Okay, so Akhilesh wants to know that he's saying that India still relies on other countries for components and expensive goods due to limited domestic production capacity and technological expertise, leading to high import costs. When will India come up with our own domestic production?
Okay, so this is a very interesting question. So let me put it this way. Okay, I think today we are in an era where global dependency cannot be removed entirely. Okay, we are going to depend on each other for various things. There will be some countries which can manufacture, for example, Taiwan. Look at Taiwan. Okay, for whatever reason, they just put their money entirely on semiconductor, right? TSMC, right? Taiwan Semiconductor Manufacturing Corporation. They just put their money on semiconductor, and the country was built around this, right? The country actually just works around this ecosystem, right? So now it may be, hard for us to just completely replace Taiwan and stuff like that, but there is also a need. So I think what will happen is countries will soon start recognizing that they need, a certain independency, right? I think that's what even India did, when they spoke about this Atmanirbhar Bharat and all that, right? Then there's a certain independence that is needed for your strategic, work, like your space defense, right? Now, for that purpose, we might come up with, some very specific stuff. But I think in general, consumer electronics and stuff like that will be interdependent globally, right? So what will happen is, what the companies will do, right, is I think they will start sort of diversifying, instead of having everything manufactured out of Taiwan, right? For example, I don't know if you guys followed the news recently, there was an earthquake in Taiwan. Now, this would have sent a shiver down every single semiconductor company, okay? Because almost all ICs basically come from Taiwan. That basically goes into mobile phones, into your cars, into everything comes from Taiwan, right? Now, what happens if there is a problem in, TSMC, right? Therefore, automatically TSMC also will start opening their fabs in the US, in other places, in Europe and stuff like that, right? India is also looking at, some sort of a semiconductor fab. There was a recent announcement by the Honorable Prime Minister that you would have seen, right? So I think there is going to be some sort of, everything will not be dependent on just one country, but it could be dependent on a couple of companies who themselves will set it up at different places in the globe, so that there is no dependence, geographical dependence or political dependence on just one place.
Yes, Professor. So what I understand from it is that countries need to be dependent on the resources they already have, right? So, for example, India can't set up any lithium-ion manufacturing plant because of the resources already available in Earth. So, from what we know is that some regions in China have lithium reserves. So that is why they have set up a lithium-ion battery manufacturing plant nearby. So it is important. From what I understand, is that it is important to utilize the resources we all have.
Yeah.
But that comes with the price of paying import duties for the components that we can't manufacture on our own.
Yes.
So it totally is dependent on the resources that we already have. Okay, so yeah, we have another interesting question, but before that, I would also like to tell that since we are in this electronic systems degree, most of us are in the next coming 4 years are going to be the future of the country, which is the main reason why all of us have joined this BS and ES program. So, and it is definitely the main part of this is that in the coming times, it is obviously everybody knows that it's the electric revolution. Almost everybody has an electric vehicle at home, an electric car, and an electric scooter. So, so we have a question from Sarat Kumar. He would like to know that for electric vehicle design, in-depth knowledge of power electronics related subjects is necessary. So, is there any course in electives in the BS and ES program to which relates with power electronics?
Yes, there is a power electronics course that will come later as an elective. In fact, I think it is there as a core. It's not just an elective. So you will have to do power electronics as part of your degree here. Yes, but that will be past the diploma.
Okay, so it will be in the BS degree level, right?
Yes, yes, yes.
Okay, so Sarat Kumar, I hope that answers your question. You can expect a power electronics course in the core level itself, as Professor mentioned, in the BS degree after 4 years. I mean, in the 4th year after diploma. And also, Professor, we as the students in ES and as the team of ROBO-SOCCER would like to thank you so much for this huge initiative of IIT Madras itself. We would also like to make a point here that since this itself revolves around electronics, the next Tesla could be from IIT Madras, the next huge revolution. Just like IIT Bombay had Ola Electric from Bhavish Agarwal, we can have something similar from IIT Madras. So that's what we all hope for, and that is our goal. And we will try our very best to do all that is necessary for attaining all those skills.
Absolutely. So thank you all. This was a very enlightening session for me. I'm very excited to see this ROBO-SOCCER event happen here, right? And then we will take it to the next level, right? I also feel there is a lot of scope in the toy industry, with the population that we have, right? I think one thing that we miss in this entrepreneurship is we don't tailor our market to our country, right? We come up with ideas which are sort of very suited for the US market and stuff. And then, of course, that product will not fly from here because you are not in the US talking to US clients and stuff like that. Whereas I feel there is a huge market for excellent toys, to sort of be made. I think IIT Delhi had a startup right on this. They had a startup. I think it is called I forget what that STEM this thing is called. Okay, it's basically you build it from scratch. They give you the parts and you assemble it and make these toys and stuff. So I think uh, we should we can really focus on some electronic systems level product that can come out of this program, and you guys are ideally suited for that. You should definitely keep these things in mind. So just don't stop with this the game that you play, win the prize, and then go have a drink and go home. Please think about how to make that a product, how to make it a good toy, and sort of make some money out of it.
Right. So
Yes, sir.
we will definitely we will put all our efforts in taking your advice, and we'll definitely make sure that the future of India is in safe hands, since we already have blessings from people such as yourself. So thank you so much, Professor, for being in this session,
Sir,
and we look forward to.
I want to ask
Yeah,
one
Vivek, please go
question
ahead.
if
Please
you
go ahead.
allow me to. Sir, so like it's a problem for many a student that many students are facing. Like we have been passionate about digital electronics and robotics. Like in my case, I've been passionate about digital electronics and robotics since my school days. But now, when we are diving into analog electronics, we are finding it a bit dull because in the case of digital electronics, what we get is are pre-made boards with integrated ICs and circuits. We just need to code them, and we need to have some ideas on like what we need to create. But in
Yeah.
the case of analog electronics, many a student face similar challenges, like how we can develop a strong interest and enthusiasm for the analog electronics to approach it with the same excitement for what we have in digital electronics, because it's a bit like dull for the learning
Yeah.
purpose.
Yeah, I mean, look, see, ultimately, this digital and analog and all, the differentiation will fade away with time. Okay, it's all mixed signal design that actually happens today. Okay, in an IC, if you look at an IC design today, right, there is very little of, when if somebody is doing circuit design, okay, let me say there's very little to say that somebody can be called as a only digital guy or an only analog guy. It's all mixed signal design. So the point is you just need to be able to understand. See, it's ultimately the same transistor, okay, that's being used in both places, right? So it's if you get so you have to get used to, and you have to get sort of, it takes some time, I know, for analog, because it's very much like an art. Okay, if you look at the way analog design happens, there are multiple ways of doing it, and therefore iterating on the most optimum solution is an art. Okay, digital electronics is slightly more sort of systematic, and you can follow a particular, you solve a K map, you simplify, you get it, you implement it, sequential circuits, how to do how to do this sequence detector, all that is very systematic, right? It's this thing. Analog can also become like that, but for that you just need to get used to a lot of things. That's why if you look at it, the digital electronics courses are sort of, you have digital systems, then you'll have some Verilog programming, and then it goes. But in analog, you would have seen we started with electronic systems thinking, then electrical circuits, then you have analog systems, then you have everything. So it is being introduced to you in a very step-by-step manner also, okay, which allows you, and most importantly, you will see a lot of redundancy. You will see the same concepts coming again and again and again and again. That's how you get used to it. Okay, for example, I'm sure you would have seen a reasonable overlap between your electric circuits and electronic systems thinking, right? A lot of the network theorems and all would have sort of been sort of overlapping. We would have re-emphasized some of these concepts. So that's the only way for you to internalize something. It is redundancy and re-emphasis of the same thing again and again in different forms. Okay, so just you need to be patient also on this. Only then you will be able to internalize it. It will not happen in one course.
Correct,
So
sir.
it is
And I
just
feel
Yes,
apart
sir.
from what
Sir,
we learn, we should also like keep on doing stuff at our own pace, side by side, and that's how like we learn. And as you just pointed out, right, the game, I mean, the toy industry. So I mean, I am a fan of anything that works on electronics and is also like a toy stuff. Like for example, I just have it here since I'm sitting. So like I made this cyber truck that I'll be getting for Paradox. Do I remove the background or something? And
Yeah,
this
yeah.
is like,
Remove your background so it
yeah, yeah,
will
one
be
sec.
good
Is it
for
Yeah,
the
yeah,
all
yeah.
right?
Wow.
It is like ridiculously fast, and it's I mean, I'm just finishing on. It will be done in a day or so. So if I just remove this part, uh, it's like basically all electronics. I mean,
Yeah. Excellent, man. Top class.
thank you, sir. I'll
You know,
I'll
you know,
surely.
and I'll tell you one thing, okay? I myself am a huge fan of remote control cars. Okay.
Yeah.
When I went to the US and came back, the first thing in Dubai I did was in 2008. I stopped by and bought a fantastic car. Okay. To my utter shock, when I went to the US now in February, in Feb 2024, even in Dubai, I did not find any of these cars.
True, sir. True.
I'm
Even
not
I didn't
able to
find it.
find
Yeah.
good remote control cars now, man. I think because of this China problem, people have really stopped getting these imported parts and it's really showing up. I mean, I'm like in Dubai, if I don't find it, then I don't know where I'll find it. So it's I don't know how many of you like these remote control cars, but it's a
So,
market.
sir, were you looking for them in like malls or probably like the old Dubai area?
No, I've gone everywhere, man. I've gone to malls, I've gone to like local shops, I've gone to these niche areas in Chennai which deal with cars. I've gone everywhere, right? So
Mm.
I so anyway, and this is great to see. Okay. So thank you all. And I look forward to meeting you guys at Paradox here, right? So
Yeah, same here, sir.
when are you guys coming? 24th or something, right?
Yes, sir. 24th.
Yeah,
Yes,
sir.
sir. We are
24th of
coming
May,
on
we
the
are coming.
24th.
Okay,
And also,
excellent.
sir, one important point I would like to make is that, as you mentioned, the things that you said right now truly inspired me, and I would like to say that this RoboSoccer as a brand, I would like to take it forward and work on the ideas that you just gave.
Yeah,
So I completely agree that there is a huge scope in this. So
sure.
even with the help of my deputy head Namai, who already has a lot of interest and experience in this, we will take it
Excellent.
forward as a brand. So thank you so much for that input, sir. We will definitely look forward
Thank you,
for
guys.
that.
Yeah.
And thank you so much for your time today. And all of us, including all the participants, look forward to meeting you during the RoboSoccer competition at Paradox. So
Sure.
Thank you,
thank
sir.
you so
Have a
much,
good day.
everyone. Thank you so much, sir. Have a nice
It
day,
was a
everybody.
wonderful session, sir. Thank you so much.
Thank you. Thank you all. I'll look forward to seeing you guys here. Okay. Bye.
Yeah. Goodbye, sir. Take care.
Bye.
Thank you so much, everybody, and thank you so much for attending this from the Paradox team. It was organized due to all the efforts from everybody in the Paradox team, everybody in the RoboSoccer team. So once again, I would like to thank all of you for joining, and thank you all of you for your time. And a huge thank you for the electronic systems community as well as the data science community. And a huge thank you, Professor, for all your valuable insights and inputs. And as I already said, we look forward to meeting you in the Paradox.
Thank you. Bye bye.
Thank you so much, sir. Have a nice day. Have a nice day, everybody. Goodbye.
Yeah, same to you.